A brief forward before we start. As you might notice, this episode is a bit different than our usual content, in that this is not really about the traditional way of doing 3D CG work, such as using Houdini or Blender. This is the second or third time that we are covering an AI topic, and I think the first time that we are covering a topic that is so accessible, and also one that's really transformative, maybe the most revolutionary change in the tools of the trade that we're seeing, at least since I work in this business. And I think instead of purely ignoring it or deriding it, we should at least give this a try and see how it fits into our workflow and how it can augment our workflow. And also, if you don't decide on using AI, that's good. I don't want to talk about the ethics of AI here. That's a whole different subject and one that needs to be discussed. However, in here, I want to focus more on the crafty part of it, the script kiddie, hacky part of it. So please use the comments to let us know if you want more of this content. And before we get started, a note on hardware. This can be hardware intense. So if your computer doesn't have a massive graphics cards with 8, 16 or maybe 24 gigabytes of VRAM, you might want to consider running Stable Diffusion in the cloud and not locally. That being said, let's get started. So the first thing I want to do is install Stable Diffusion locally. And for this I decided on a project called Stable Diffusion webUI by Automatic 1111, which I think is a really good base. And to install that, the first thing I usually want to do is create a new user, as typically I'll be installing certain Python versions. And instead of setting up different environments, this is kind of my poor man's or lazy way of managing those different environments. So in Windows, I'll just go to the Windows menu and start typing users or user, and go to add, edit or remove other users. And in here, what I want to do is add an account. And now I'll have to try really hard to convince Microsoft that I don't want to create a Microsoft account, which I can do by clicking I don't have this person's sign-in information, add a user without a Microsoft account, and then let's give this user a username. Let's call it Stable Diffusion for now. And in this case, I decided to be extra lazy and extra unsafe and not use a password. So do that at your own risk. And now I created this new user here. And for now, it's set to be a local account. However, for installing software, I need the proper rights, which in this case I will gain if I set this account to be an administrator. So I'll click on this and change the account type here. And the account type I'll set to administrator and hit OK. So now that I've created this new account, I want to switch into it, which I can do by clicking here on the Windows icon and then on my currently active user, and then clicking on Stable Diff here, the new user. So after I've signed into this new user and went through the initial setup of that new user, I'm greeted by this. And after launching my browser, what I want to do is search the web for webUI, maybe add Stable Diffusion. And then the first link should lead me to the GitHub repo of Automatic 1111, which is this repo here called Stable Diffusion webUI. And that's what I want to install. So down here, when I scroll down after the features, I can see under installation and running, I will go through the exact steps listed here, installing it on Windows. The first thing I need to do is install Python 3.10.6. So let's go through that. And in here under the Python releases, I've got to scroll down a bit. And here we do have the 3.10.6. So I'll download the Windows installer, in my case, the 64-bit one. And after a few seconds, that's downloaded here. So let's execute it and check add Python 3.10 to path. And then uncheck install launcher for all users, because we only want to have this in this single user here. And let's click install now. All right, that was successful. So let's close that and go back to the installation instructions. Now we have to install Git. So also let's click just here and download the standalone installer, in my case 60-bit for Windows. And again, after a few seconds that's ready, so let's execute that as well. And I want to allow this app to make changes and want to install this. I don't want to view the release notes and just hit finish. All right, back to the installation instructions. What else? So now we'll have to create a folder into which we'll download the webUI here using Git. So let's first create a folder. In this case, I will go to my local disk, which is already pretty full. And I'll just create a new folder in here. Let's call that sdiff for Stable Diffusion. So now I want to open up the command prompt by going to the Windows icon here and typing cmd and then starting the command prompt here. And in here, the first thing I want to do is go back to my root and then go into the Stable Diffusion folder, which I can autocomplete by typing SD and then hitting tab. It'll try autocomplete to the existing folder. So let's go in here and see if there's anything in here, and it's not. And let's just try executing this command here. Let's copy everything, including this dot here, and just paste it. And what I want to do now is insert a space before the dot like this. And this will tell Git to just copy the contents of this repo here into this folder without creating a new subfolder for this. So let's hit enter. And after a short while, we download it and copy it those files into this folder here. Let's try listing the directory again, and we can see, yes, we've got our files here. Now, in order to be able to actually create images, we need model checkpoints. That means pre-trained models, which we're going to use to create images. And we can see a list of those models here under dependencies. And in this case, I want to use the Stable Diffusion model checkpoint. Let's click on official download, which will lead us to Hugging Face. And down here, you can download the weights. And this is kind of an older checkpoint. There's also Stable Diffusion version 1.5 and the newest one, the version 2.0, which I can find by searching for models up here. And automatically, I get suggestions what other people looked for. And in fact, here, the Stable Diffusion 2 is what I'm looking for, which is the newest Stable Diffusion checkpoint, at least at the time of recording this tutorial. And under Files here, I can scroll down and download this 768 vema.checkpoint by just clicking here and then waiting quite a long while until these 5-point-something gigabytes have downloaded. I'll cancel that for now, as I've already downloaded that checkpoint, so let's just cancel this here. And I'll just gonna go into the Stable Diffusion folder that I just created, go into the model subfolder, and then into Stable Diffusion, and in here I will copy the checkpoint file, which I just downloaded, which is this one here. Alright, back to our Stable Diffusion webUI page. One more thing we need to do in order to be able to use Stable Diffusion 2.0 is, when we're scrolling down here, going to the Stable Diffusion's 2 support here under features. Let's go to the wiki. And we already downloaded this checkpoint here. However, now we need the config file here and set that up accordingly. So let's just click here. This is the config file, so let's just save this one here, hitting Ctrl S in our browser, and then navigating again to our Stable Diffusion folder. And in here again, I'm gonna go into the model subfolder into Stable Diffusion, and then instead of calling it like that, I will call it exactly like this checkpoint here. So 768 -v -ema. So let's copy that, set this to be all files, and then paste the file name in front of the YAML. Like this. Let's save this. Seems to have worked. So let's go back to our webUI and let's again scroll down to the installation instructions. And well, that should already be it. So let's try by going up, scrolling down in our Stable Diffusion folder here and starting the webui.bat, which is the Windows batch file here. So let's double click on that and this window will pop up. And when you are first starting the webUI for Stable Diffusion, that's going to take a while. So don't be irritated. This can take anywhere between 10 to 40 minutes. Because we're installing a bunch of libraries here, downloading those, so depending on your internet speed, this can go faster or slower. Yeah, 10 to 40 minutes might have been optimistic. I think this took over 90 minutes. However, once you are greeted with this line here, and let's just copy this URL here by double-clicking on it and then just hitting Ctrl-C, and then opening your browser, opening a new tab and pasting this URL there, then you are finally greeted with the Stable Diffusion webUI. So let's start prompting. Up here, we should be able to select our checkpoint, the Stable Diffusion 2.0 that we copied. And down here, we have a bunch of settings, which will generate an output image here. Let's go over them. First, let's enter a prompt here. Let's go with the very popular horse riding an astronaut. And also, we have the possibility to enter negative prompts. That means stuff we don't want to see in the images we generate. Next, we have a variety of sampling methods, which are used to generate the output image. And online, you are able to find many grids, which show the different results these algorithms produce. For some of the plugins or some of the custom scripts in here, it is necessary to use Euler or Euler A. However, in my experience, the DDIM sampler almost always results in faster, more cleaner images than the Euler sampler. So let's go with this one, and let's increase the sampling steps. That's the steps Stable Diffusion takes to denoise your initial noise into an image. Then let's select the width and height of the output image. I'll go with 768 by 768, which is the exact resolution that this checkpoint has been trained on. Sometimes when generating portrait images or photos or images of humans, it is helpful to enable restore faces, which helps you keep human faces that this algorithm generates from looking mangled, distorted, or asymmetric. In the batch count, we can enter how many images we want to generate, in this case only one. And finally, on the CFG scale, we can tell the algorithm how serious it should take these prompts here. And anywhere between 5 and 12, in my opinion, is, well, do kind of this what I tell you here. Below 5 is go loose, do what you want. And above 12 is really seriously, honestly, do this what I tell you here. In this case, I'll go with a CFG scale of maybe 9. And down here, I can input a seed. By default, this is set to -1, which means that each time I hit the generate button, Stable Diffusion's webUI will randomly choose a new seed, which I don't want. So I'll just enter my very creative seed of 1, 2, 3, 4, and then click generate. And to see what's going on in the background, let me just bring up the command window here again. And you can see here is a more precise depiction of what's happening in the background. And once our process is finished, we can go back to the browser and we can see horse riding an astronaut is, well, an astronaut riding a horse. So let's see what happens when we give a negative prompt of astronaut riding a horse. And again, let's hit generate. Well, that only partially worked, and that is because my prompts suck. So let's talk a bit about the few tiny things I found out while trying to come up with prompts. The main thing being that with this new model, the Stable Diffusion 2.0 model, most prompts that you read on the internet do not produce good results anymore. Because the part that interprets the text input here and turns it into a bunch of values that then drives the diffusion algorithm on how it generates the output image has been changed in Stable Diffusion 2.0. So what can we do to come up with good-ish prompts here? Well, we could look at how clip, this is the underlying model that turns our prompts into numbers, which then guide our algorithm, how this model describes any existing images. So for example, let's just search for maybe a spaceship. Why not go with a cliche? Or maybe a space fighter. Let's see which images come up. Let's also maybe make sure we have a Creative Commons license here, which of course makes life harder as my selection is quite limited in here. Maybe let's search for a more concrete object. And indeed, let's go with the Soyuz capsule here. And let's just drag this image into our clip interrogator here and hit submit. This one is running online in the cloud, so it'll take a while to process this, which of course I'm going to skip again. And after a bit of waiting, we can see this is the description of this image given by the clip model that's built into Stable Diffusion. Okay, let's just copy this and go back to our Stable Diffusion here. And let's just paste this in here and maybe delete the negative prompt. And again, let's see what we generate out of this. And well, it is something. Maybe not necessarily the highest quality, but it's a start. So again, let's try some negative prompts to guide this a bit better. Let's say we don't want something that looks mangled. We don't want something that looks too disconnected. We don't want anything that looks naive or surreal. We don't want illustrations. We want to be more photoreal. So let's also exclude painting and sketch. And let's see. All right, getting there. We also don't want any Earth in the background. So let's not do a space station in the sky, but in space maybe. And maybe let's adjust this here a bit and add a few names of spacecraft. And again, let's generate something. And we are starting to get somewhere. So let's generate a bunch of these. And maybe when looking at these again, some of these details look as they wouldn't make proper sense. So what we can do for that, for the image to converge a bit better on something more plausible, is again increasing the sample steps to maybe, let's say 60 steps. Again, let's just have a look at this single image before we start generating a bunch of them. And well, debatable if this is more plausible or not, but we'll just roll with it and maybe add a dark background in the prompt. And again. So let's just roll with this and generate a bunch of these images, because let's face it, working with these kinds of AIs, at least as of today, changes happen quick in this area, means generating a bunch of images and then selecting, cherry picking the few that we really like. So instead of just generating one image, let's say maybe let's generate 25 images and hit generate and wait a bit. Again, let's bring up the command window in the background. So now we can see what's going on here. So we're generating image after image after image. The sad thing about this is we would have to wait until all those images are finished, until they're displayed here in the browser. So instead what we can do is go to our installation directory of Stable Diffusion, which in our case is this, and go to the outputs folder and then into the text to images images. And in here, Stable Diffusion automatically saves all those images it generates. So we could just double click on those images here and using the picture viewer, just skip through them. And when looking through those images by now, you realize that my prompting skills suck. And I'm pretty bad at this. So instead of trying to describe what I want with an elaborate text prompt, why not use an image or images to guide Stable Diffusion, which luckily we can do. Let me just interrupt this calculation here by just clicking the interrupt button in the webUI here. Takes a bit, and then we can see the results as well as a grid made up of our resulting images. So instead of using purely a prompt, let's also use an image to guide Stable Diffusion. For that, I will just copy the prompt I have here and go to the image to image tab. And in here, I will add my prompt again, and also I will add my negative prompt again. And then in here, most of the settings are exactly the same as in the text to image. However, I can add an image here, which Stable Diffusion will then use as a guide. So let's find something that does not look extremely terrible, or maybe something with a neutral background. Let's go with this one. Drag this one in here. And again, let's set up the width and the height to 768 by 768. Increase our sampling steps to maybe 50 in this case. Sampler is the DDIM. Down here we have the same setting for batch count and for the seed, so let's enter a fixed seed here. And now next to the CFG scale, which tells the algorithm how strongly it should adhere to these prompts, we have this denoising strength here. And the denoising strength tells the algorithm how true it should stay to the original image, with a low value resulting in almost the exact same output as the original image, and a high value of 1, resulting in something that totally deviates from this image. And depending on your subject and on your prompt, you might want to play with this and might want to vary this. I had kind of good results with anything ranging between 0.6 and 0.75, depending on the subject again. So let's also output a bunch of those, let's say 9, and let's generate a few images. Again, bringing up the output folder here. And in this case, it's not written in the text to images, but in a second into the image to images. So in here, I can already find the first few examples of what we just created. So let's skip through them, and we can see, yes, we are kind of adhering to the image that we fed into, but also generating a bunch of alternatives. However, this also suffers from my really bad initial image that I just prompted. And again, my prompts aren't good. So instead, what I like to do is render out some simple image using Houdini. And in this case, I've got a few cheap and quickly thrown together spaceships, which again, let's try generating a bunch of images based off of this. And again, let's have a look into the output folder. So here we are starting to see those initial images. And at this point, I'm thinking, yes, some of those already work better than the input. However, what if I could just take one of those images and feed it back into the image to images algorithm so that we generate a new version of this image instead of the original badly rendered images that I put in there. And we can do with what is called a script. So Stable Diffusion's webUI by default comes with a bunch of scripts which hide in its scripts folder. So instead of the output folder, let's go to the Stable Diffusion scripts folder in here, and you can see a bunch of Python scripts here. And this does exactly what I mentioned. So it feeds back an output image of this algorithm to itself as a new input. We can decide how many times we do this game. In my case, I only want to do it 2 times. So once to generate the initial image, and then one more loop to use the first image that we generated, again to generate another image. Then we have a denoising strength change factor down here. That means that this denoising strength, and by now it's set to be a bit liberal with the image content, might change between each of those loops. So it could either get bigger to allow the algorithm more freedom with each successive loop, or it could get smaller to restrict the algorithm to converge more and more into a single image. And let's maybe feed it back not only 2, but 3 times. Okay, again, we have a batch count of 9, so 9 times 3 should be 27 images now. Let's generate those. And already after a few images, I can see something weird happening. So this here is my first image, which is fine. And then generating a new image out of that as a base image results in this, which is also fine. And then using that as a base image for the next image, also fine. However, the further we progress in this series, the more similar all those images get to my input image. So what is happening here? Well, actually, there's a small bug in the Loopback script down here when used in conjunction with the batches up here. What's happening is that after each batch, so after 3 loops, the denoising strength is not reset to its original value, which means my images converge more and more into exactly the same image that I fed in there. So let's do a bit of script kidding, and let's fix that script by opening up Stable Diffusion's scripts folder and then opening up the Loopback here. In my case, I'll be using Sublime, I think, but you use whatever you like. So here we've got this Python file, and hell is other people's code, but don't worry, got you covered. And the first thing I want to do is save this under a different name. So maybe let's save this as, maybe let's go for loopback_02.py. And also let's give this another name when this thing is displayed in our web UI here. So let's call it loopback fixed and save this. Now down here in the run is where the magic happens. Here we are running through a loop for all the batches, and within those batches we are running the loops for, well, actually the loops. So how many times we're going to feed back the image into itself. And what I want to do is, after each of those loops here, so after this body has run, I want to reset my denoising strength to the value that we entered here in this field. And I can do that by setting up a new variable up here, and let's call it initial underscore denoising underscore strength, like this. And let's set it to this value that we entered here in the denoising strength, here in this tab, which you can access by calling our currently processed object's denoising strength, like this. So now we store this denoising strength into another variable called initial denoising strength. And now, when we are running through this batch loop, that means for each batch, what we want to do here is set the denoising strength to its initial value that we stored in a separate variable called initial denoising strength here. And that, fingers crossed, should be it. So let's save this. And in order to make this available here in our script, we need to update this. And when updating all this, our prompts get lost. So what I'll do is in Sublime, I'll create a new file and just copy my prompts in here. So let's copy this and paste it here. And also let's get the negative prompt and post it in here. All right, now let's reload our scripts by going to the settings, then scrolling all the way down, and down here hitting restart Gradio and refresh components. That takes a short bit, and then under image we can set up our parameters like we used to have them. Let's go with 50 sampling steps, DDIM 768 by 768, do 9 batches, CFG scale of 9, denoising strength, let's leave it at that, seed is fixed. And in this case, let's use the loopback fixed. And here let's do 4 or 5 loops, and let's reduce the denoising strength each loop. Also, let's add our guiding image in here. Let's generate. Again, let's go to our Stable Diffusion's output to see what's happening. Image to image images. And down here, we can see our first images appearing. So let's wait a bit. And indeed, we don't seem to be converging on that same exact image we initialized this whole process with. So let's just have a quick flip through those images. And yeah, debatable. I could really work on my prompting skills here, which I think I will do in order to create an artwork for this tutorial. And I'm going to provide you with the prompts that I used for that artwork. But that is my quick-ish take on what I found out poking into Stable Diffusion's webUI and getting more and more intrigued by it. I think especially the possibility of going into Stable Diffusion's scripting folder and adding functionality here using a bunch of Python libs is really helpful and really powerful. And also the idea of initializing Stable Diffusion in image-to-image mode using images that are generated procedurally in another tool, for example Houdini, is what makes this method really powerful in my opinion. And if you want to learn more or plainly want to support us, consider becoming a patron of ours, as it is through the help of our patrons that we are able to run Interrogator. And to everyone already supporting us, thanks so much. With a very special thank you going to Supermassive Games, Jellyfish Pictures, The Mill, Method Studios, Electric Theater, Via, Pixonic, Random42, Rodeo Effects, Side Effects, Lusion, Styleframe, and Rafik Anadol Studio. Thanks so much. And as always, and this time particularly, I am intrigued to see what you folks cook up using that technique. So until next time, it is cheers and goodbye.